Let us now discuss the type 2 problem. So what would be the type 2? As I have said already, fillet weld is present on two sides, but the length of the weld is unequal. Okay. So what is the question now? The question is, a tie member of a truss consists of ISA 65 by 65 by 6 mm of Fe 410 grade is welded to an 8 mm gusset plate shown in the figure. Design a weld to transmit to the full length of the member. Assume shop welding. This is a question. So what is the important note that you have seen from the question? You have understood. It is an angle section. So that it is a truss member. So there is a gusset plate and an angle is fitted to that. It is welded to the gusset plate. So welding is done on two sides of the angle. One of L1 and another of L2. So this is the thing. Okay. So how will be the solution for Fe 410 Newton per mm square? Your Fy would be 250 Newton per mm square. And the gamma MW is 1.25 for shop welding. Which plate do we need to take? We are going to do the welding on both the side of the angle. So we have to take the thickness of the angle. So T is equal to 6 mm. Now, as it is an angle, we have to use a steel table to identify the area and the centroidal distance. Oh, this is from the steel table. So we will get the AG and CZ sets. This value can be obtained for the corresponding ISA 65 by 65 by 6 mm. Okay. So this is the first basic thing. So you know step 1. What will be the step 1? We need to calculate the size of the weld. So minimum size of the weld. Now it is an angle. So how will be the edges? It is a rounded section. So we know from page number 79 that size of the page number 79, clause 10.5.8.2, size of the weld should generally not exceed 3/4 of the thickness of the section of the toe. If it is a rounded toe, okay, if it is a rounded one, so S should be less than 3/4 of T. And maximum size formula is always standard, T minus 1.5. So minimum is 4.5, maximum is also 4.5. So I have gone for S is equal to 4 mm because size should not exceed, should be less than 4.5. So greater than 3 but less than 4.5. So I went for 4 mm. Okay. Next is the step 2. We need to calculate the effective throat thickness. What is TT? TT is equal to K into S. You know what K? K is equal to 0.7. That is available on page number 78. Okay. On table number 22. We saw in the last problem. Next is the calculation of the effective length of the weld. So, design strength of the weld will be PDW is equal to LW into TT FU by root 3 gamma MW. Here we will get PW in terms of LW. TT, you have identified throat thickness. These values you know, so substitute and you find PDW in terms of LW. Tensile capacity of the number. TDG is equal to AGFI by gamma M naught. What is AG? Steel table. FI you know, gamma M naught also you know. So you know you can identify TDG. So equating these two, TDG is equal to PDW, you will identify LW value. But if it was of uniform length, you would have simply divided by it 2 and provided on both the sides. But it is of unequal length. So there will be an The fourth step will be little different. So determining L1 and L2. So what is a hint? We have to equate the CG of the weld to the CG of the angle. CG of the, not just equating. It is with respect to CG of the weld is equal to with respect to CG of the angle. So CG of the angle section is at a distance of 8.1 mm from top. This is obtained from the steel table. This only we have this value and we know the total value. So we can determine this value. So this first part is over. It is not directly this one. It is with respect to. With respect to. Okay. So with respect to the length. Now you see this is the values we have. If you see this drawing, it is a simply supported condition. You have a load. Here the load will be that P, and here it is opposite P1 and P2. So you can see it is a simply supported condition. So L1 into gamma 18.1 is equal to L2 into the other distance. L1 into this one is equal to L2 into this one. You can take any of it as L1 and L2. Okay. So from that you can identify L1 in terms of L2. We know LW is equal to L1 plus L2. Right? So what is LW? LW is 318.91. LW is 318.91 is equal to L1 plus L2. So we have obtained L1 in terms of L2. So substituting 3 here, 318.91 is equal to 2.59 L2 plus L2. From this L2 is equal to this much. So L1 is equal to what? L1 is equal to 2.59 L2. So 2.59 into L2. So you'll get this value. Provide L2 is equal to 90 mm, L1 is equal to 235 mm. Got it? This is very simple. So some general mistake most of the student does is they would have taken this value and they take this value as LW, which is wrong. This is ISA 65 by 65 by 6. So this is 65. That's 65. This is not LW actually. Okay. So very simple. So we have identified L1 and L2. So L1 is 235 and L2 is this much. Thank you.